I'm Anil Kumar. This video is for grade 10 IB students who are just learning about angles and radians. So we have taken up 6 examples here. We'll figure out the relation between angle in radians. Let us say we have a circle, then that angle theta we'll talk about, and radius r of the circle. And then we'll also look into the arc length. These three things are very much connected, right? So the relation between them is A equals to r theta. So if I draw our standard triangle, just to remember, right? Just as we do distance as velocity into time, then the arc length A is equal to radius times the angle theta, right? So that is the relation. So we can write A equals to r theta, where the angle theta is in radians, where theta is in radians. Radians is a ratio of length, so basically it's not a unit, but just we call this as radians. If you see angle without any unit, it means angle is given to you in radians, right? So this equation will be used to answer first 3 questions where we are talking about determine angle in radians and degrees. So when I say and degrees, how are they related? Well, you know 2 pi, which is full circle in radians, is equals to 360 degrees, right? Full circle, 2 pi, 360 degrees, and definitely half of it, that means pi radians, is equals to 180 degrees, correct? So that is the relation which can help you convert from degrees to radians or otherwise, right? So these 3 examples are straightforward. You have to only remember that if you use this formula A equals to r theta, then theta should be in radians. Perfect. Then we have 3 word problems which say a 20 centimeter pendulum swings through an arc of 15 centimeter in 0.2 seconds. Find angle and the average angular velocity. So angle you can find with r theta and A relationship. For angular velocity, omega, we normally write this with a Greek letter omega, which is written like this, right? So angular velocity, angle in time. Do you understand? And the units are radians per second. Is that okay? So simple. Angular velocity means angle moved and time taken. So that ratio in radians per second is angular velocity. So simple, right? So you have to use this relation to calculate the answer. I'll provide all the solutions just after we discuss this page. You can always pause the video, copy these questions, try them yourself, and then check your solutions. The next question is, a small electric motor turns at 2200 revolutions per minute. Express this as angular velocity in radians per second. And second part of this question is, find the distance, a point 0.9 centimeter from the center of the rotation travels in given time, which is 0.008 seconds, right? So here we have to combine these 2 formulas, A equals to r theta, omega equals to theta by t, right? You see the connection and then get the answer. The last question here is, Ferris wheel with a radius of 25.3 meter makes 2 revolutions. When I write r, so r basically means revolutions. So in 1 revolution, you do 2 pi radians, remember that. 1 revolution is 1 full circle, 360 degrees, and in radians it is 2 pi radians. So it makes 2 revolutions per minute. Find angular velocity and the distance moved by the rider in 4 minutes. Distance moved will be arc length A, right? So I hope the questions are very clear to you. Now let us see how to solve them one by one. Now in your calculator you have to be very careful about the settings. That is to say, You may have to change it to radians, that is helpful. You might need degrees sometimes, correct? So let's begin answering these questions one by one. The very first question here is, determine angle theta in radians and degree measures. We are given three different scenarios. The connection between theta, radius and arc length is A equals to r times theta, right? So if you want to find theta, we need to rearrange. So we say theta equals to arc length divided by radius. Remember, theta is in radians, correct? And if you don't write any units, it is assumed to be radians. Perfect. So if the angle, whatever angle you want, it will be always given in radius. To convert to degrees, what do? We use a relation that 180 degrees is equal to pi radians, correct? So that is how you're going to solve this question. So let's begin. The first one, we need to find theta. So we can find theta in radians directly using this relation. 6 meters, so it is A over R. So in the first case, A is 6 meters over 4 meters, right? So you get your answer, which you could write as 3 over 2, or in this case, let's just say 1.5. No units, since meter cancel, but we could always write radians, right? So whenever you use this formula, it is radians, which is basically ratio of lengths, correct? So let's find all the angles in radians first. So here theta will be equals to, we're talking about this big angle, correct? So we'll take the big arc, which is 12 millimeters, right? Divided by 4 millimeters, which is 3 radians, correct? The next one here is theta equals to, now theta is that angle. However, we are given these sides. So let me call this as theta dash, right? So we'll call theta dash because when I divide 10 centimeters by 3 centimeters, what I get is the angle, which is the big angle, right? So theta is going to be, I have to take away 10 divided by 3 from 2 pi, right? So let's calculate this first. So we'll do 10 divided by 3, which is in decimals, it's recurring, right? So let me write this as 3.33 recurring, right? So that is radians, bigger angle. But we need theta, which is 2 pi minus 3.3 recurring. So we'll do now 2 times pi, and then we'll take away 3 point, let me write this like this, okay? So the answer in radians is 2.9498. Is it okay? Which could be rounded to 2.950. If we round to 1000 place, if we round to 100 place, it is 2.95. So at times in this type of question, you may be given that round your answer to 100th place or something like this, correct? So you have to do rounding accordingly. Perfect. Now, the second part of this is to convert degrees, radians to degrees. So now we'll do radians to degrees. Okay, so that is important to understand. Now, as you know, 180 degrees is pi radians. Now we get here 1.5 radians, correct? I want degrees. So what I will do here is that I'll times it by 180 degrees, right? So get radians and divide it by pi radians. Do you understand? So as you can see, the units, radians cancel, we are left with degrees. So that helps to calculate. So I hope you have understood the concept, right? So we'll do 1.5 times 180 divided by pi. And that gives us 85.9436. And let us round this to 100th, 2 decimal places, right? So we'll do this as approximately 85.94. correct? So we approximate to 100th. This one we did 1000. Perfect. So what you need to do here is, whatever you've got as your angle, you have to multiply that by 180 divided by pi, correct? So theta and degrees will be written like this, correct? So this place, let me just divide the page. Is it okay? Now here, theta is so many radians. So if I have to write theta in degrees, it will be 3 radians times 180 degrees divided by pi radians, correct? That is what it is. Use calculator, figure it out. Similarly, do this one, right? So you have to multiply by 180 degrees and divide by pi to get your answer. Perfect. So that is the conversion factor. So in each case, you times the radians by 180 degrees and divide by pi radians to get the answer. So I'd like you to find the answers for part B and C, right? Let's move on. So now we are doing very similar exercises. I'll do 1 or 2 of them. You do the rest. Determine the length of each radius r. So we are given arc length and theta angle, right? So we know the relation, which is, let me write down the relations here. We know A equals to r theta. If you want r, we can rearrange this as r is A over theta, where theta is in radians. Perfect. As you will observe, here we have given theta in degrees, here we have given it in radians. Let me solve both of them. That is an exercise for you, correct? Okay. Now in this particular case, we know theta is in radians, arc length is in meters, radius is A over theta. So radius is arc length of 2 meters divided by theta, which is pi by 3, correct? Or I could say 6 meters over pi. So radius is in meters. The setting should be in radians whenever you're working with 6 divided by pi. Let me redo. 6 divided by pi is equals to 1.909, which I'm rounding to hundreds now, 1.91. Is it okay? So 1.91 and the units are meters. Now in this example, we are given theta in degrees, 80 degrees. We should convert that to radians. How will you do it? Multiply by pi radians and divide it by 180 degrees. So degree will cancel. You're left with units, radians, correct? So let's do it. So we'll divide 80 by 180 and then multiply by pi to get the answer, which is 4.9 pi, and in decimals it is 1.3962 whatever, right? Now, so that is the angle in radians. If I don't write anything, it means radians, correct? So r is equal to A, which is 3 meters in our case, divided by this number, which is theta, 1.396, okay? So we'll divide 3 by 1.396 to get angle, to get the radius, which is equal to 2.148, right? Which you can round to 2.15 units are meters. Perfect. So we have done this. Now in the last example, you have to find the arc. We are given arc length of 10 centimeters. You have to find radius, and outside angle is given to you, 300, right? So this angle, theta for you, I should write now theta dash, because theta is given to you as 300, correct? So for us, theta dash is 360 degrees minus 300, which gives you 60 degrees, correct? You have to convert that to radians, right? So to convert to radians, you will multiply by pi and divide by 180. degrees, correct? So you get pi by 3 radians. Now you can calculate r by finding ratio of given arc length 10 divided by pi by 3, correct? Calculate this answer. So I hope this is clear to you. Let's move on. Similar exercise, it is only for your practice. Now here we need to find what is the arc length A when the angle is given to us and the radius is given to us. So I'd like you to do the first example, which is straightforward. We need to find the arc length A. And we know A is equals to r times theta. We're given both the values, you can multiply and get your answer. Angle should always be in radians. Perfect. In the second case, we are again given radius and the angle theta. However, angle is given in degrees. So you have to write the angle theta in radians. First convert degrees to radians by multiplying them by a factor of pi over 180. And that gives you pi by 3, right? Pi by 3 radians. Once you know radians, you can say arc length A is equal to radius times theta. In our case, radius is 10, units are millimeters. And the arc length will be 10 times pi by 3. And the units will be in millimeters, correct? So we can always use the calculator. We may round our answer to hundreds. So we'll do 10 times pi, and then we'll divide by 3. In decimals, it is equal to 10.471, which can be rounded to 10.47, correct? So you can round your answer to hundreds. Okay. The last one here, we need to find the bigger arc length. We are given the smaller angle. So you have to be careful. So this angle, let me call this as phi. So phi for us will be 2 pi minus pi by 3, correct? Which is 6 pi minus pi, which is 5 pi by 3. Does it make sense to you? So the big angle is 5 pi by 3. And therefore, the arc length A should be equals to 3 times 5 pi by 3. And the units, last time the units will be millimeters. Here, the units are in meters, correct? So that is how we get. So exact value is 5 pi meters as these 3 cancel. And rounding to 100 place, we'll do 5 times pi equals to, in decimals, 15.7079, so which is 15.71 meters, correct? So I hope with these 3 questions, you are fairly comfortable finding arc length, that is angle theta or radian, when 2 are given and 1 is missing, right? Now let's get to now word problems, which might be difficult at times. Okay. The question here is, a 20 centimeter pendulum swings through an arc of 15 centimeter in 0.2 seconds. So let's say this is the pendulum, right? So let me make some big and bold diagrams. It helps to understand. Let's say that is how it swings, right, from one place to another. And what we are given here is 20 centimeters is this length, right? So this length is 20 centimeters. So we know the radius of the arc is 20 centimeters. Swings to an arc length of 15 centimeters. So this is 15 centimeters right there. And that is the arc length. A is 15 centimeters. Perfect. And time taken for this swing is 0.2 seconds. We have to find angle. Let's say this is the angle which we have to find, and the average angular velocity. So we have to find 2 things. First is the angle, and then we have to find average angular velocity omega. Now angle A equals to r theta, right? So angle is A divided by r, right? So remember the triangle which we have. Let me make it here just for us to remember it. Just as we have distance, speed, time triangle, so A is r theta. Simple as that. So r or theta is ratio of arc length over radius. Is it okay? Like this. So in our case, arc length is 15 and radius is 20. So their ratio is the value. So let's do 15 by 20 divided by 20 equals to, in decimals, 0.75. 0.75, and this unit is radians. Correct? So we have theta in radians. Angular velocity is angle, which is in radians, over time taken, right? Over time taken, which is in seconds. Simple. Angular velocity. So angle for us is 0.75 in radians, and the time taken is 0.2 seconds, and so we get our answer, right? So let me divide this by 0.2 to get the answer as equals to 3.75 radians per second. Do you see that? So that is how you'll find omega. Okay. Now for some of the students who are also doing linear velocity, let me give a relation here. Linear velocity, which is v, is omega r, right? So at times you may be asked to find the linear velocity. Then you have to multiply omega with r to get. Correct? So the units will be, in this case, centimeters per second, right? Well, I'm not asking it now, but it could be. Let's look into the next question, which is a small electric motor turns at 2200 revolutions per minute. So this is our angular velocity omega, which is sometimes also given as revolutions per minute. Okay. Express this angular velocity in radians per second. That's first part. Then find the distance, a point 0.9 centimeter from the center of rotation travels in this much of time. So the second part, we are given the radius as 0.9 centimeter and we are given time as 0.008 seconds, and we have to find the arc length A. Correct? That's the next part. So think like this. We have a motor here which is running, correct? And the point from the center somewhere there is moving. That is the situation. Okay. So let's see how to do these questions. So first part, I'm using a very general way of converting units from revolutions per minute to radians per second. Now, one revolution, let's try to understand this concept first, right? So one full circle, if you go one full circle, it means what? So you know, one revolution, let me write down here, one revolution will basically means 2 pi radians. Is it okay? And you know, 1 minute is 60 seconds, right? So that helps us to convert, and let us see how to convert. So we are given here angular velocity omega as 2200 revolutions per minute. Now we don't want revolutions, we want radians here. So I have to divide by 1 revolution, right? And 1 revolution is 2 pi radians. So I'll multiply by 2 pi radians, correct? So that is going to help us to get radians in the numerator. Now what should I do with minutes and seconds? I have minutes here. I have to cancel this minutes. So I'll say 1 minute is equal to 60 seconds. So that helps to cancel the minutes. So in our formula, we get omega equals to 2200. Then we are left with 2 pi here, correct? And the unit is radians. Do you see that? And in the denominator, we have 60 and the units is seconds. Does it make sense to you? So that is how you're going to do the conversion. Let's do it. Calculate. 2200 times 2 times pi and then we'll divide by 60 equals to, so let's get the exact value, the rounded value. So which is 230.38 radians per second. Do you see that? So let's round it to the whole number, which is 230 radians per second, correct? Okay. So we got the angular velocity. So we've done part 1. Second part, find the distance a point 0.9 centimeter away. So r is given to you from the center, travels in this much of time. So how will you find the distance? That means a, right? Now a is r times theta. So you have to find theta first, correct? How do you find theta? Theta is related with angular velocity. You know angular velocity is ratio of theta with time. So you could write that theta is equals to angular velocity times time. Perfect. Now since theta is angular velocity times time, I can substitute it right there, correct? And so we get our new formula. A, arc length or distance moved, is r times omega t. Is it okay? So r is given to us 0.9. Omega we just found, we'll multiply by 230 point, let's just say 38, and then time is 0.008 times 0.008, correct, to get the whole thing. And the units will be the units of radius, which is centimeters. Perfect. So let's do this. So it is 0.9 times 230.38, that is times 0.008, and that is equals to 1.658 centimeters, correct? Okay. 1.658 centimeters, which you could round to 100th place if required, whatever. But anyway, you have understood how to find the distance moved by the tip of a blade in this case, which could be on the electric motor running. So here, conversion of units from revolutions to radius per second, and then how arc length is related with radius, angular velocity, and time. Just multiply all three of them, right? Now we are almost at the end. The last example before us is about the Ferris wheel. I'd like you to pause the video, copy the question, solve it yourself, take it as a test question. Now I hope you have got the right solution for this last question of my series on angular velocity and arc length. The question here is Ferris wheel with a radius of 25.3 meters. So we are given radius of 25.3 meters, makes 2 revolutions per minute. So that is angular velocity. However, the units are 2, let me write revolution as REV per minute. Now the question is find angular velocity and the distance moved by the rider in 4 minutes. Now if I were to write find angular velocity, when we say it is always in radians per second. Is it okay? So we have to first convert this to radians per second. So you know 1 revolution is 2 pi radians. So we can write omega equals to 2 revolutions per minute. To convert to radians, we'll say 2 pi radians is equal to 1 revolution. And as far as minute is concerned, we know 1 minute is 60 seconds. So that gives us the answer in revolutions per, radians per second, right? So minute cancel, revolution cancel. So we get here 4 pi over 60 radians per second. Let's convert it, write it in decimals. So we have 4 times, let's write 4 times pi divided by 60 in decimals is 0.2094 radians per second. Okay. Now the second part of this question is distance moved by rider 4 minutes in 4 minutes, right? So time taken is 4 minutes. So we could write this in terms of seconds, which is 4 times 60, right? 240 seconds. So distance moved is arc length. So when you move, you're going in circle, correct? So you're going A. So A equals to R times theta. And we know theta is omega times T. So A will be R times omega times T, correct? So the distance moved will be the radius, which is 25.3 meters, right? And omega is all this, which is 0.2094, and time is 4 minutes, which is 240 seconds times 240. And the units will be same as radius units, meters. So let's do this calculation. 25.3 times 0.2094 times 240 gives you 1271.47 meters. Correct? So that is the distance moved in this particular case. So that is how you could actually solve this particular question. So I hope this exercise helps you to understand how to work with radians, how to convert to degrees, and the relation A goes to R theta, which is valid only when theta is in radians. Omega, the angular velocity, is angle turned over time, so it is theta over t. Normally, angular velocity is in radians per second. You could always convert revolutions by multiplying them by 2 pi into radians, and then the units, minutes into seconds, you know, a factor of 60 helps to do it. We also learned that the arc length could be also written as product of radius times angular velocity times t. Feel free to write your comments, share your views, and if you like and subscribe, that'll be good. Thank you, and all the best.